Hey everyone, Johnny here, and welcome to another video. I'm going to be explaining how to actually work out a savings plan. So if you're saving an amount of money, the same amount of money every month, for instance, for a fixed amount of years, let's say 20 years, what will the value of your total investment be by the end? Okay, so how do you figure that out? So let's lay out a scenario as an example. Let's say that you're a prudent saver, and this is a pretty good savings plan. It's realistic when you have a full-time job, hopefully. So let's say you're saving $2,000 a month is being saved, okay? It might be less, it might be more in real life, but that's about $500 a week. That's a pretty good amount to save if you can. So you have $2,000 a month of savings. You take the $2,000 to the bank. Obviously, you might actually do this online, but just to make you understand it a little bit more, imagine you have $2,000 in cash, and at the start of every month, you go to the bank and you give them $2,000. Now, why would you give it to the bank instead of saving that money under your bed or somewhere in your house? Because a bank is going to pay you interest. Okay, so you're going to save $2,000 a month, give it to the bank, because a bank will pay you interest, okay? And let's just say, for example, the interest rate you're getting on the money you give to the bank is 3% per annum, and per annum means per year. So the bank is paying you 3% per annum on the amount that you have saved. For example, if you had saved $2,000, not for a month, but for a whole year, so let's say you put $2,000 in a bank account at the start of the year and left it and did nothing else, then by the end of the year, that $2,000 will have earned 3% interest on top. So this is the interest. This is on top, right? So when you go back to the bank at the end of the year, you would have the $2,000 that you put in plus 3%. And 3% is, I believe, $60, right? Because 10% is $200, therefore 1% is $20. So 3 times 1% is going to lead you to $60. So if you put $2,000 in the bank at the start of the year at this interest rate and do nothing else, you would walk away at the end of the year with $2,060. Okay? $2,060 would be the 3%. However, in this case, we're not doing a one-off investment. We are not putting money in once at the start of the year. What we're doing instead is going every month to the bank to give another $5,000. Okay, so this is each month. This is each month. Okay, so 3% per annum is in interest, and also we're interested in how long we're going to have money sitting in the bank. Let's say you're able to save $2,000 a month, non-negotiable, for 20 years. Let's see what would happen to that money, okay? So here are our circumstances. The last thing we need to clarify is how often the bank is going to pay you interest. And typically what you'll find is they don't just pay you interest every year, they pay interest every month. So it's compounding monthly. Okay, it is compounding monthly. And because the bank is paying you interest every month and not every year, the annual interest rate doesn't really mean as much to us because the bank's never actually going to apply the 3% rate. What they're going to do is say, look, we were going to pay you 3% per year, but because we're going to recalculate the interest every single month, we need to convert. We need to convert the 3%. We need to convert the 3% per year into a monthly interest rate. Now, how many months are in a year? 12. So what you do is we divide the 3% by 12 because there's 12 months in a year to get a monthly interest rate. And that's going to give us 0.25% is the interest rate, is the interest per month. We're more interested in that number, okay? So the number we actually care about here is this one, okay? And this will represent our R. So our interest rate is 0.25%, or we can write it as a decimal, and you can do this in a calculator, 0.0025, because we add 2 zeros, because we are dividing by 100 to convert from a percentage to a decimal. Okay, so that's the interest rate we're interested in. By the same token, we also need to change the period. So at the moment, we said we're interested in 20 years' time. But remember, everything's in terms of months now because the bank's paying us per month. So I actually only care about how many months we're going to be making the investment of $2,000. And the answer to that is 20 years. We do 20 years times 12 because there's 12 months in a year. So how many months are there in 20 years? 240 months. Okay, so the relevant N, the relevant period, okay, the period of time that we're interested in is 240 months. We don't care so much about the 20 anymore because it's compounded monthly. Everything's happening on a monthly basis. Now we have that information clarified, we can start working towards a pattern. We can try and see a pattern that happens when we start taking the new $2,000 every month to the bank. Okay, so let's see what happens to our money. And the best way to do this, the best way to figure this out is to start by writing out what amount of money will be in the bank after the first 3 months, and then try and develop a general formula so you can predict, or you can know for sure rather, exactly how much money is in your account at any point in time. So we don't want to go through and figure out what's happening every single month. Let's write out what's happening for the first 3 months and try and see if there's a pattern, and then see if we can find a shortcut by using a formula that might be relevant to then allow us to find how much will be in the account at any point in time, especially after the 20 years or the 240 months. Okay, so let's start by figuring out how much money would be in the bank account at the end of the first month. So the amount in the account at the end of the first month. That's what this means. This is at the end. So the amount at end of month 1. So what actually happened here in real life? You went to the bank on the 1st of January of a particular year. You gave the bank $2,000. When the end of the month comes around, so it now is the 31st of January, how much is in your account after interest has been applied? Because you get interest. The bank rewards you for having money in their account for a month. So you know you put $2,000 in at the start of the month. Now the bank has applied interest, right? So you receive interest, but also sitting in your account is the original $2,000. So we put a bracket here. We use a compound interest formula. And you can have a look at a separate video on the compound interest formula for more information on that. But basically we have the $2,000 bracket because we're going to multiply by 1. Now that might seem funny, but the reason we're doing that is because obviously at the end of the first month, we still have the original $2,000 that we put in. We haven't lost that. But we get additionally, we do a 1 plus, we get 0.0025, which remember is the same as 0.25% in interest. Closed bracket, right? So not only do we have $2,000 times 1, we also have $2,000 times 0.25%, because you have the original amount plus the interest that the bank pays you. So the amount of money at the end of the first month is going to be given by this expression. Now we can simplify that bracket by making 1 plus 0.0025 simply 1.0025. So there's our expression. We don't need to get the exact amount here because we're trying to get a pattern. So don't put that into your calculator. We are trying to see a pattern that emerges, so we don't actually want to get exact numbers for now. Okay, so the amount after the first month is that. What about the second month? What about the second month, right? What's happened in the second month? Well, 2 things happen. First of all, the amount of money that was sitting in the account after the first month, which we just said was this, is going to get interest applied to it. So imagine that we didn't make any extra investment and we just had the original $2,000 that we did at the start of the first month, right? 1st of January, gave $2,000. What happens at the end of the second month to it? Well, what happens to it is whatever was the result of the end of the first month gets the interest applied to it in the same way. And of course, the original amount is still in there. So the 1.0025 gets multiplied by the amount of money that was in your bank account at the end of the first month, because you get interest plus you keep what was already there. That's the 1. Remember, that's the 1 plus. But something else has happened in that second month. Something else has happened. What's happened is you've added another $2,000. And that's why we call this situation where you have a regular amount of money going into an account, or if you're making regular repayments to the bank, but in this case you are doing regular savings, we call all of this whole kind of situation where there's a regular recurring payment, we call it an annuity. So you can think about this as a type of annuity question, okay? Because it's not a one-off payment. You're making the $2,000 payment again and again and again every month. It could be every year. It would still be an annuity question. Okay, so you've added another $2,000. This is the second time you've gone to the bank and you added another $2,000, separate to the first $2,000. And that $2,000 obviously gets one round of interest because it's been sitting in the account for 1 month. But here's the important thing. This $2,000 in green is the second $2,000. It's only been in the account for 1 month. Whereas the initial $2,000 that you put in the first month has now been in the account for 2 months. So it has received 2 rounds of interest. So look at what happens when I substitute in for A1 the expression here. Because remember, A1 is the amount after the first month, and we know that's given by 2,000 bracket 1.0025. So if I substitute that in there, instead of writing A1, I'll write what it actually did equal before. Okay, and then it multiplies by the 1.0025 there. And then, of course, we add the 2,000 here. I'll try and keep this color-coded for you. We add the $2,000 here. And, of course, that gets the 1 round of interest. But look over here. Look carefully. Remember, this new round of interest, this is the new round of interest in blue. That is that part. That bracket there, that second 1.0025 is the new round of interest. Whereas that first bracket here, this bit here, the 1.0025 here, that was the first round of interest. Remember from the first bit of working that we did? So we carry that over. And what happens is you'll notice that this bracket times this bracket, they're exactly the same. So that's going to become 1.0025 squared. So let's go up to rewrite this line out. So to finish off with the second month, we have the amount in the account at the end of the second month is going to be 2,000. 1.0025 bracket squared, because again, remember, we had 2 brackets that are the same times in one another. And then we had plus 2,000. The second 2,000, that was our second payment, but that only received 1 round of interest so far because it's only been in the account for 1 month. So that's the expression we have there. That's the second month. What about the third month? Now, you might be thinking at this point, geez, this is going forever. It won't go forever. This is the last example I'm going to show you so you can clearly see the pattern that's emerging. Then we can create a general formula, and then you can find out how much will be in the account at the end of the whole 20 years or the 240 months. So at the end of the third month, A3, the amount in the account at the end of the third month, right? This is going to equal, in much the same way, it's going to equal A2. It's going to whatever amount was in the account after the end of the second month, which we know is this expression, that is going to be multiplied by 1.0025. And by the way, I'm not writing the times there, but there is an invisible times between A2 and 1.0025. Okay, and then of course, what's happened in the third month? Well, at the start of month 3, we went to the bank and we added another $2,000. So far, we've invested $6,000 because we've been to the bank 3 times and given them $2,000, but each $2,000 is part of a different account, if you like. It's part of a different category because it's receiving a different amount of interest by the end because each amount is in the account for a different amount of time. So each $2,000 receives the same interest rate, but the interest rate applies to each $2,000 payment a different amount of times, right? So we have a different power. That's why we had squared and then we only had 1 there, because one $2,000 payment had been compounded twice, the other one had only been compounded once. Okay, so what we now do is we get this expression from A2 and substitute it there, because we know that the amount that was there at the second month gets another round of interest. The bank pays you another month of interest on that amount, plus they'll pay you 1 round of interest on the new $2,000. Okay, so what you'll end up with here is all of this. See this expression here? There's actually 2 terms there. You can see the plus sign here. The plus sign splits the 2 terms. Now, if I multiply 2,000 and then this bracket by that bracket, okay, so I'm applying 1.0025, I'm multiplying these by that, and I'll just write it out so it's very, very clear. So the A2 is the same as this expression, so here is A2. Here is A2. I'll write it out in full just in case, because I don't know where you're up to with your understanding, right? So that's A2. Let's put that in brackets. And what we've just said is we're going to multiply that. We're going to multiply that by 1.0025. Okay, so all of that's going to get multiplied by 1.0025. Now, if I multiply that, that's going to become cubed because it's already got squared and I'm multiplying by another one of the same brackets. So, and remember, we have the extra $2,000 down here that's being multiplied by 1.0025. Okay, so all of this is A3, is the same as this. Okay? So make sure you pause it and try and re-watch what I've just said to try and understand where each thing is coming from. But if I expand the red bits by this bracket here, we're going to end up with $2,000 to 1.0025 to the power of 3 plus $2,000, 1.0025 to the power of 2, because again, this one only had a 1. This one had an invisible 1 here. See this? It had a 1 above it, this second bracket, and now it has a 2 above it because it got multiplied by another one of the same thing, another round of interest. Plus, right? Plus, now we just bring in the new $2,000, the new $2,000, which has 1 round of interest because it's only been sitting in the account for 1 month. Okay, so now what we can do to help us get towards a general formula is we can factorize out the 2,000, because look at all 3 terms have 2,000 in it. So let's factorize. I'll put that here. Let's factor or factorize this, right? So a common factor here is $2,000. I know that 1.0025 is also a common factor, but we can leave that for now. Okay, so we have 2,000, and then I'm going to do a big bracket here to not get the smaller brackets confused. I do a square bracket. And 2,000 times what gets me back to my first term? Well, it's 1.05 to the 3. Now I want to get back to the second term, so it's plus 1.0025 to the 2, plus the third term, which is 1.0025, right? And then close that square bracket. So that is the same thing as what we have there. Now that we've factorized it, we can clearly see a pattern. Hopefully you can see it. That within the square brackets, there is actually a pattern. Each term is going down or up by a multiple of 1.0025. So what I'm going to do now is I'm going to rearrange the bracket, right? I'm going to rearrange the bracket. And you'll see why in a second. So it's going to equal 2,000. And I'm going to put the smallest one first instead, right? It's exactly the same value. 1.0025 plus 1.0025 squared plus 1.0025 cubed. See here, it's exact same as that line. I've just rearranged the order from smallest to biggest. And hopefully what you can now see is that ignoring the $2,000, if we ignore the $2,000, we can see that within this bracket is a GP, a geometric progression. because each term is going up by a multiple of the same number. Now, what is that common multiple? See here, it's going up by the same number. To get from this one to this one, and then this one to this one, we multiply by, let's put it here, the R is equaling 1.0025. To get from the first term to the next one, you just multiply by 1.0025. So that's part of our GP. And the first term in the GP is not 2,000 because that's actually excluded. That's on the outside. We will hold that there, but it's not part of our geometric progression. And we will say that the first term is 1.0025. Now, if you had factorized the 1.0025 out along with the 2,000 and then had the square bracket, you will find that the first term is 1. So it would be 1 plus, and then you would change that accordingly. But I'm going to proceed on this basis, right, that we just factorized out the 2,000. Now, because we have a GP, clearly here they're plusing each other. So we need to use the formula for finding the sum of a GP. Now, if you can't remember what that formula is, I'm going to show you here. If you can't remember what that formula is, the formula for a sum of a GP where the rate is greater than 1 or less than, or R is less than -1, which is the case here because remember our R equals 1.0025, so it's greater than 1, right? The sum of a GP is going to equal, and I'll just take this sheet away, and watch our other video on the sum of a GP if you're confused at all by this. It's going to equal A R to the N minus 1 over R minus 1. So that is the formula for the sum of a geometric progression of the kind that we see in our brackets. Remember, we saw a geometric progression emerge here, so we can now use that formula in a more general way. So remember, we had A3, we have A3 there. We can now make a general formula. This is what you do after you do the first three. You do ... and you say A to the N. We can now estimate what any month is going to be, the value of your investment after any month, by doing $2,000, because remember, the 2,000 is just always sits out the front. And what will happen is the amount of terms in the bracket is going to reflect exactly what month it is. So see here how it's the third month. How many terms are in the bracket? 3. And what's the highest power? 3. Whereas when we had the second month, if you look back up here, the highest power was 2. So that pattern is going to just continue. So what we can say is we know that any month, the value of the investment at any month is going to be A, which is 1 point, and just to make this super clear for you, any month is going to be 1.0025 plus 1.0025 squared plus, and it's just going to keep going until we get to 1.005 to the n. So if it was the 10th month, we would make that power 10. These would just keep going up until we got to the power of 10. Okay, but we know from above that this is a GP, and we can just summarize the sum of all of this using the formula I just showed you here. So have a look at this. AN is going to equal 2,000 bracket. Now, what does the formula say to do? Put the first term out the front. What did we say the first term was? We said it was 1.0025, okay? That's the first term. And then it says to do, what does it say to do next? It says to do the rate, which we said up there was 1.0025 as well. So sometimes that will happen. And it says to do that to the power of n, which is just going to be however many months we're interested in for the question. I'll put this back up for you. And then it says to do minus 1. And then we're going to divide all of that by 1.0025, take away 1, close bracket. So that's just me applying the sum of a GP formula because I established that we are going to have a GP all the time for this pattern. So now what we can do is we can simplify some of this. Okay, so pay careful attention here. This is important. A lot of people miss this step. If we have $2,000, right? If we have $2,000, what we can do here next to it is write the bracket, but instead of writing this numerator and this denominator, I know that this part simplifies to 0.0025, right? You could just see that in a calculator. But what we can do next is actually divide, because this is all part of one fraction, and because this number is multiplying by this whole bracket, we can actually divide 1.0025 by 1.0025 minus 1, which is 0.0025. So in other words, we can divide this number here that I've circled by this number here. We can divide them to give another number and get rid of the denominator. Okay, so what is that number going to be if I divide those two together? We are going to get 401, and you can put that in your calculator. So that blue number divided by the denominator here equals that, and then that leaves us still with the 1.0025 to the power of n minus 1. Okay? But hey, that's a little bit simpler. So some people would see in a question the 401 and they'd be very confused. Where did that 401 come from? Well, it comes from this number dividing by that denominator, okay? What we can do next, of course, is multiply the 2,000 times the 401. Even though it's a big square bracket here, there's nothing stopping us from timesing the 2,000 by the 401. All of these things are basically timesing together at this point. So that is going to equal 802,000. And then again, we are left with, because these are all multiplying each other, 1.0025. This is still wedged in the bracket. Minus 1 with the power there. And there you have it. That's a simplified expression for what it's going to be. So a to the n is given by this expression, which makes things really easy because now we can find the amount of the investment at the end of 240 months. Have a look at this. The amount at the in the account at the end of 240 months, which again is the end of the 20 years, is going to equal 802,000 bracket 1.0025 to the power of 240 minus 1. And when we put that into our calculator, you're going to get the following answer. You're going to get $658,245.51. And there you have it. That's what the value of your investment is after 20 years. Now, that number might not mean that much to you right now, but have a look at this. If you've invested $2,000 for 240 months, right? This is the total savings. So your total savings that you put into the account, right? All the money that you put into the account yourself would equal $480,000. So that's the accumulation of all those $2,000 monthly payments. So that's really good. $480,000 you saved after 20 years just by putting about $500 a week into an account. So this is some real life stuff. That's pretty good. However, that's not as good as what the bank has given you back. The bank has given you back $658,245, even though you only put in $480,000. And the reason for that is because they have paid you interest. So how much interest have you actually earned? How much additional money has the bank given you? How much have they rewarded you with for putting the money in the bank with them instead of putting it under your bed? Remember, if you were stashing the $2,000 every month for 20 years under your bed or somewhere in your house, you would only have $480,000 at the end of the 20 years. But if you gave the $2,000 to the bank who paid you 3% interest per annum, compounded monthly, then you make an extra, this is an extra amount of $178,245.51. That is additional to the money that you invested. So the bank didn't merely store your money, they actually rewarded you with more money, and a lot more money. So I hope that is a very useful explanation for you. I know it's a longer video. I tried to explain every single step for working these kinds of questions out. If you've got any questions, put them below. If you enjoyed the video, please like, please subscribe to the channel as well. Most importantly, if you want to see more of these videos, love to hear any of your feedback, and I will see you in the next video.